In the previous video, we were introduced to quadratic equations, what the standard form of quadratic equations look like, and the first method on how to factor quadratic equations. The first method being you factor out the greatest common factor. Now, you will not always be lucky to be able to find a greatest common factor and factor it out. So, method number 2 for factoring quadratic equations is called the backwards FOIL or the AC method. And you can use it to try and factor quadratic equations to help solve for values of x if the equation is factorable. So, let's look at this first example. So the first example, we have the expression x squared minus 12x plus 36, and they are asking us to factor. We cannot factor by the greatest common factor because all of the terms do not have any number or variable in common that you can divide out. So we are going to factor using the AC method. So what you should do is list out your A, B, and C. My A is 1, my B term is negative 12, and my C is positive 36. Then, after you write out your A, B, and C, you multiply your A term by your C term. So 1 times 6 is positive 36. After you multiply your A times C, you want to find what two numbers will multiply to give you a positive 36, and what two factors that will add to negative 12. So they have to be the same exact factors that multiply to positive 6, but when you add them together, they will give you negative 12. So what you should do is list out the possible factors of your A times C term. Here it's positive 36. So, 1 times 36 will give you 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. Notice that I have a plus or minus symbol in front of all of the numbers. When I have a product that is positive, I am either taking two numbers that are positive or two numbers that are negative to multiply together to give you a positive result. So observe the different factors and see which numbers multiply to give you 36 and add to give you negative 12. Here you should notice that if you took the numbers negative 6 and negative 6, they multiply to give you positive 36, and they add together to give you a negative 12. Now that you have found your two factors, you want to take these two factors and divide by your A coefficient multiplying the variable x. Your A coefficient multiplying by your variable x, because this is x squared. So x times x, you would eventually get an x squared in there, and then you take it by the A coefficient. Now, after you write them into fraction form, you want to simplify the fraction as much as possible. Here the fractions are already simplified, so that's good. We don't have to worry about this step. So, now that they are simplified, you have your two products already. You just have to rewrite them. The first would be x subtracting 6. So that is my first set of parentheses. And my second parentheses would be x subtracting 6. Here we ended up with the same exact binomial multiplying itself. This is considered a special product, or squared. So when you are fully finished with factoring, you can always double check that your answer is correct. You can have x multiplying x to give you x squared, x multiplying negative 6 to give you negative 6x, negative 6 times x to give you a negative 6x, and then a negative 6 times a negative 6 to give you a positive 36. you can multiply these binomials by the distributive property or the FOIL method that I just did, or you could always use the box method where you are finding the area, whatever method works best for you. Now you combine like terms, and you are left with x squared minus 12x plus 36. And if you get the same exact expression from the beginning, then you know that you factored it correctly. Let's look at another example. We have 2x squared plus 15x minus 8. I am using this example because we do not always have a 1 for our a term. Here we have a 2 for our a positive 15 for our b, and negative 8 for our c. Be careful, the a times c term would be 2 times negative 8, which gives you negative 16. Here I want to find two factors that will multiply to give me negative 16 and add to positive 15. So what I'm going to do is list out the possible factors: 1 and 16, 2 and 8, 4 and 4. The less factors you have, the less options you have to look through, and the easier it is to finish the problem. Now notice our 16 is negative. That means we are going to be taking a product of a negative number and a positive number, and we need to make sure that the smaller number is going to be the negative number because we want the sum to be a positive solution. So the smaller number is going to be negative for the sum to be positive. Now, after looking at the possible factors of positive 16, the factors of 16 that will multiply to give you the negative 16 and add to the positive 15, you will notice if you take negative 1 and positive 16, they multiply together to give you negative 16. They add together to give you a positive 15. So the two factors we have here are the negative 1 and the positive 16. What you do here is divide by the a term, which is 2, and then multiplied by the variable x. If this variable was a different letter, then obviously that letter is going to match. So if it was y, I would be writing a y here. Then this one I'm going to be dividing by the a term and then multiplying by the variable x. And I want to simplify. Here, this fraction, right here, this fraction you cannot simplify because 1 and 2 are already fully simplified. But here, 16 and 2 are both divisible by 2. So 16 divided by 2 is 8, 2 divided by 2 is 2. So now both of these fractions are fully simplified, and now you have your final solution. You just need to rewrite it. So rewriting the solution, I have 2x minus 1 because it's negative, and then I have 1x plus 8 because it is positive. And again, you set each of these fractions into their own set of parentheses, and you are done with your answer. You can always double check by multiplying the binomials together. And if you would like more YouTube videos to reference, here are some great YouTube videos that I think will help you with this method some more. Now let's practice. They want us to factor the following expressions. I will do questions 1 and 4 for you, and then I will expect you to try the rest on your own. So number 1, we have our a term is 1. Our b term is 10. Our c term is 21. Then you want to take a times c. That's why I call it the AC method, because you multiply a times c to get positive 21. So I want to find factors of 21 that multiply together to get 21, but add to positive 10. You can list out all the factors of 21. You are going to get 1 and 21 or 7 and 3. Now, out of those combinations, you know that 7 and 3 in a combination could get you the sum of 10. Now, this is positive 21, so either 7 and 3 are both positive or they're both negative. Now 10 is positive here, so I know I need both of them to be positive to add to positive 10. Now that I have my two factors, I'm going to divide by my a term, multiplying the variable that I have. Here my variable is a, because that is the variable I have in the equation. So instead of the x like the examples, I have an a. And again, over here, I'm going to divide by the a coefficient and the variable that is in the equation. Now, I have to simplify these fractions. They are fully simplified, so my final answer is going to be a plus 7 multiplying a plus 3. And that is my final answer for number 1. That is fully factored. Now number 4, I have a. My a term is positive 3. My b term is negative 11. My c term is negative 4. A times c is going to be negative 12 because positive 3 times negative 4 is negative 12. So I want to find factors of negative 12 that multiply together to get negative 12 but add together to get negative 11. Factors of 12 are 1 and 12, 2 and 6, and 3 and 4. Out of all of those factors, you will notice that if I take a 1 and take a 12, in some way, I will get a negative 11. So it's negative 12, and I want the sum to be negative 11. That means the negative must be on the 12, and the positive must be on the 1, because you want a negative sum. That means the larger number has to have the negative. Then what we do is divide by the a coefficient and the variable in the equation. So the variable in this equation is x, so that's why I'm going to put an x here. Same thing on this fraction as well. Now this first fraction is fully simplified. I don't need to simplify it any farther, but this right fraction can be simplified by dividing 12 and 3 by 3. So negative 12 divided by 3 is negative 4. And then 3 divided by 3 is 1, leaving you with the x. So these are my two fully factored fractions. Now that you have them, you can write them in parentheses. I have 3x plus 1 is my first set of parentheses. And then I have x minus 4 is my second set of parentheses. And this is the fully factored form of this problem. Now, please pause the video to try questions 2, 3, 5, and 6 on your own. Whenever you are ready, you may press play on the video to look at the solutions. Here are the final solutions. As long as you have each individual set of parentheses correct, it doesn't matter the order that you wrote them in. Like, here, if I did a plus 3 first and then a plus 7 second, that is okay. Just make sure that the specific variables and numbers are together in one set of parentheses. It doesn't matter which set of parentheses was first. That concludes how to factor quadratic equations. Please watch the next video on how to find solutions for quadratic equations.